Ladies and gentlemen, welcome back. I hope you had a nice snack. And during the break, we are moving forward with our program. Our actual topic, which we want to present you at the moment, is the circular economy in the construction sector. Our first speaker, Mr. Zerobin from the RECENT, is right over here. Please, Mr. Zerobin, stage is yours.
Thank you very much for the kind introduction. Good afternoon from my side. In the next few minutes, I'm going to talk about contactless sensing technologies for enabling efficient process control. And first of all, I need to, So maybe you probably heard from the last presentations and from the presentations from today, several keywords from digital transformation, big data, regarding the industry, but regarding climate neutrality, you heard probably carbon neutrality, green industry, small CO2 footprint, and of course, circular economy. And in order to reach that climate neutrality, one point is fundamental. Metrology or sensing is fundamental on the one hand to gain data, and on the other hand, to understand and optimize those processes. And we, at our company, it's called RECENT, and from the name, you already see our focus. We are a research center for non-destructive testing. We are a research and technology organization, non-academic, which focuses on sensing technologies. We've got 7 research areas, from acoustic technologies like laser ultrasound and photoacoustics, over to optical technologies like infrared and Raman spectroscopy, over optical coherence tomography and terahertz technology. And since autumn last year, we also have a research group which is dealing with quantum sensing, which is quite an interesting topic. Still in, of course, there's a lot of research going on there, but that will be very interesting also for industry applications in the next years. And our focus is bringing those technologies from the laboratory to applications in the industry. That is our focus. And how to do that? Basically, we are offering quite a broad range, from proof of concept studies over R&D consulting. We're doing sensing development and prototyping in-house. We're doing the whole system integration, where we integrate our sensing solutions to your process systems, or your systems in the industry, in your process. And we also offer measurement service, where you can send in your probes to our facility, and we are analyzing those probes, for instance, regarding microplastics. And as written on the top of that slide, we're dealing with material characterization, quality inspection, and process analytics, that ranging from applications in a laboratory to the process itself, to inline applications, as seen on the right-hand side. But what they have all in common is they are non-contact and non-destructive solutions. And today I want to focus on one specific technology, on the infrared spectroscopy, since this is a key technology for inline process control and inline process monitoring. Our custom-specific measurement solutions are mainly based on in the recent years, some really small MEMS-based spectrometers, which are quite robust, compact, and low cost. And with these 3 features, we are able to design several kinds of measurement setups. There on the left side, you can see a fiber-based setup, or on the right-hand side, you can see a non-fiber-based, depending on the application. And what are we measuring? Since we are a research and technology organization, I have to do a little bit theory, but it's not too technical. But what are we measuring? We are measuring basically the molecular vibrations of the material, of media. So, for instance, what I'm showing here is an example of water. We are measuring with those spectrometers the absorbance of water. And what you get is a characteristic spectrum, which is basically a spectral fingerprint. And therefore, you can characterize any material or any media chemically and can identify those media very precisely. Now I'm showing you some examples based on that technology. The first one I want to show is an inline monitoring of the resin production. For applications on the left side, you can see, for instance, for the production of melamine formaldehyde resins for surfaces or phenol formaldehyde resins for mineral wool. What we're doing here is an inline chemical characterization. So at the company, in that case Metadinea, we're applying our microspectrometer downstream of the formalin tanks, and with that microspectrometer, we're measuring the concentration of formaldehyde. And now we are able then to monitor this production. That's a 24/7 batch production. We are able to monitor that production, and since it's inline and automated, we can also automatically do a real-time process control. And that, with those advantages, we can then reduct, or had then a reduction of the online measurements by over 90%, and of course can then in the subsequent process also use the reactor, the chemical reactors, the space of the chemical reactors more efficiently. And with those advantages, the company was able to reach a saving of approximately 200,000 euros per year, which is quite a lot, of course. Another example would be the determination of moisture. As I showed before, that's based on the inline evaluation of the water absorbance, so the characteristic spectrum of water. And when you do measure that, you can see, that's in the middle of the picture here, you can see the spectral absorbance at the specific wavelength. And we can measure that at the various of different media, from powder over pellets, over flakes, over cramps, foams, or wool, but also viscous media, or for instance, also concrete. And the big advantage here is we are non-contact and non-destructive, so that means there are large measurement distances possible. And of course, with this small measurement head, what you can see here, it's also possible to do that inline and automatable. And of course, you can use those data then to real-time process control, to establish a real-time process control. And of course, when looking at the moisture, when you do the measurement over time, you get, of course, something like the picture above here, a drying curve. So you can monitor your drying process. So you can measure moisture over time and control your drying process. That can be done for water, of course, for drying processes, but we can also do that for curing processes, for instance, of curing of epoxy-based materials or media, for resins, as demonstrated in the picture below. You can see here the characteristic infrared absorption. Is that the, yeah, here. The characteristic infrared absorption of the primary amine and secondary amine over time. And with those data, you can then determine the curing. In addition, you can also monitor additional parameters like mixing ratio or concentration with that technology. Another example, which is semi-based, I would say, on infrared technology, is the inlet characterization of layers. We're using here primarily the optical coherence tomography and terahertz technology. With those technologies, we can determine the layer thickness and the internal structure of various products or various materials, like multi-layer films or sheets, like laminates or vinyls, like composites or hybrids, and multi-layer pipes, for instance. Some examples are shown here, where the multi-layer foil is analyzed, and where you can see the structure, or here for a multi-layer pipe, or for this picture, where the structure of a foam is evaluated. And with those technologies, we are able to reach really high penetration depth, depending on the technology, from some millimeters to several centimeters, and really high resolutions down to some micrometers, which can be seen here in that foil. The scale here says 200 micrometers, so we can really see some very thin layers and can characterize them. And the last one the last example I want to show you is the detection of contaminations. That's now an example which is not for an inline process control, but for an offline quality inspection. We can here identify those contaminations and characterize those contaminations by localization, chemical identification, and quantification on several materials, like, for instance, of soil, of textiles, or of foams. Sorry, that was one page too fast. Here, exactly. One example would be, for instance, the analysis of microplastic in soil. What you can see here, that's, for instance, a soil sample, quite a small one. And from that soil sample, we can look at a region of 300 times 300 micrometers. And from that region, we can zoom in and see particles down to 250 nanometers and can identify which plastic are within this region. So, for instance, here PET is identified in those bright regions, which are quite small. Or, for instance, here different adhesives on the textile. We can here identify which adhesives and localize them and quantify how much of that adhesive is applied on that textile. And with that technology, we are able to produce those results quite fast and precise. So I'm already coming to the conclusion and to the summary of today's presentation. So I showed you some examples for non-contact and non-destructive measurement solutions, which are mainly based on the custom-specific sensor systems, based on the small spectrometers, which are robust, compact, and low cost. And I showed you just some applications and some examples, mainly based for the chemical industry and for the construction industry. But of course, those examples can also be applied at different and many other industries. So thank you for your attention, and we are looking into it. So that's our mission. And if you have any question, I'm happy to answer it. Thank you.
Thank you very much, Mr. Zerobin. It was a very interesting presentation. Please tell us also how the people can connect you if they have any questions.
Sure.
They can connect you. You are still staying here. Very nice. Thank you very much.
Thank you.
So we are moving forward. Our next guest today is Mr. Marc Guido Höhne from the Delta. And his topic is also very interesting: circular real estate, challenges and pathways. Thank you. You're welcome.
Yeah, thank you for the invitation to give you an overview of the challenges and pathways of circular real estate. After probably having zoomed pretty much into a lot of details today, I will zoom out again, yeah, and trying to make a big picture. But who am I? I'm Marc Höhne. From a background, I'm an architect with a 26-year experience in project management and architecture, but the last 10 years mostly focusing on sustainability. The Delta Group is for 47 years on the market. Here in Austria, services include architecture and planning or general planning, project and construction management, as well as consulting with a strong focus on sustainability. We are based in Austria, Czech Republic, Slovakia, and Ukraine, with an overall of 450 employees. Sustainability has been a strong part of the Delta DNA for the last 40 years, mostly focusing on partnership approaches in the beginning, but since the last 15 years, more and more focusing on sustainability in construction. Coming to challenge number 1, design and planning. Traditional construction practices are often linear, with little consideration for end-of-life material use or recycling. Shifting to a circular model requires fundamental change in design philosophy to prioritize modularity, adaptability, and the use of recyclable materials. What is a pathway? Designing buildings and components to be easily disassembled. And this is a major challenge, because not just finding the right materials, but also implementing them in the design process. We at Delta, for example, have developed our own approach, supporting our planning team with individual experts from the integrated consulting team and special tools and software. Challenge number 2, and I guess this picture generated with ChatGPT describes this pretty well. Finding reliable resources of reclaimed and recyclable materials that meet quality standards and that they will be really challenging. The market for such materials is still developing and may not always offer the needed quantity and variety. And we are also lacking of the right data and the platforms where they can be collected and where these materials can be offered in the future. What will the pathway? Yeah? Prioritizing materials that can be recycled or reused, not only by reducing waste. And here you see a good example by Werner Sobeck from Germany, who is pretty much into that topic. He designed a building with reused elements and recycled materials. And even if we should have the data collected on the platforms, then we still have a different challenge. It won't make sense to transfer materials that you probably have from a building in Italy, transfer them to Denmark, because that doesn't have a good impact on the carbon footprint. So it will need it will need regional approaches when it comes to circular real estate. Challenge number 3. The initial costs of implementing circular economy principles in construction will be much higher than traditional methods due to the costs of sourcing, the redesigning processes, and potentially longer timelines, especially in the beginning. And I tell you, we are pretty much in the beginning of circular real estate. So what is the pathway? New business models can be one, such as material as a service. Here you see a good example from Rauw Architects from Netherlands. Actually, it's not material as a service, it's a light as a service from Philips Lighting. And the challenge here was, or the approach that Thomas Rauw developed here, was that you don't buy lighting, you lease it. And you lease it for a certain time and then give it back to the supplier. Talking to manufacturers and suppliers show that this will take a huge paradigm shift in our business, because what we see is that most of our customers don't want to lease materials or lighting. They want to own it. And so it needs adaptation to these models and probably other alternatives. Challenge number 4, regulatory and market barriers. Existing building codes and industry standards are often geared toward traditional construction. Little modular, little flexible, glued and stuck together, which cannot be separated according to type, making it really difficult to integrate innovative and circular practices. In the past, manufacturers and suppliers felt no pressure to change because the market was huge. That has to change. Regulatory even got more complex than 10 years before. And additionally, market demand for circular buildings is still evolving. So, what is the pathway? It will need more advocating for and adopting policies and regulations that support circular economy practices in construction, which can help overcome market barriers. And I guess a good example, what we see here in Vienna, was Do-Tank Circular City Vienna that was founded 4 or 5 years ago, where City of in Vienna invited, or there was actually a tendering process, different companies applying with developing a circular economy strategy for refurbishment and renovation of the city of Vienna. And that is now implemented in most of the projects in Vienna. But it can also mean research and development, because investing in research and development can lead to new materials, technologies, and methods that facilitate circular construction practices. But from my point of view, it will need more regulatory pressure from manufacturers and suppliers to change and adapt their products towards circular practices. Some of this will come probably from the planners, builders, and developers, and even buyers via the EU taxonomy requirements. We see that in our current projects. But it will also need a regulative incentive or special funding to speed up the processes to develop new products. Challenge number 5. There's a need for upskilling and educating industry professionals about circular economy principles and practices, as they differ significantly from conventional construction methods. And I wished I could do something on the construction site, or even in the office once in a while, having an academy with some of the professionals I work with. From our experience, or from my experience in teaching master students in architecture and real estate management, knowledge in terms of circular real estate is still little, and the topic is not really part of their curriculums. In the construction industry, they act in terms of taking the path of least resistance, feel little pressure to change. That has to change. And even some of my colleagues from general planning think this way, but the young, they want to change. For them, it's going too slow, and the frustration level, because when budgets for sustainability are cut it down again because of budget over limit, is frustration poor. Therefore, we have implemented a Delta Academy in our company to teach our professionals about sustainability. Another pathway could also be, and it will be very important, building partnerships among manufacturers, suppliers, builders, and even regulators to foster a shared approach to circular construction, driving innovation and standardization. A good example we are working, or what we try to implement right now, is early contractor involvement. So that means that we have the builders or the construction companies on board in an early stage. And from my point of view, it would be helpful also to have the suppliers, manufacturers on board to discuss circular solution. But it will also need partnerships between manufacturers and universities, yeah, to drive the change. And it will need special training and education for a new profession, the circular engineer. Last challenge, measurement and certification. This picture shows it quite well. It would be great having a passport of each building on the building to see right away in terms of what materials are inside, what is the energy performance, and you could really judge it. But developing metrics and certification systems to measure the circularity of buildings and materials is still challenging, but essential for promoting accountability and progress. Imagine we had a digital building or land register where you could find all data about materials and their life cycle, all energy performance indicators, and you could even have a TDD prepared via pushing a button. That would be perfect. And it would be a perfect basis even because we would have all the data to, for the first time, prepare a national climate strategy on real data. What will be the solution, or what will be the pathway? And I guess that's the most important one we have to work on. That are the material passports. Implementing material passports that detail the composition and reuse potential of building materials can facilitate their recovery and repurposing. In the meanwhile, it's a must when you have green building certifications or prepare green building certifications with DGNB or Höhne. And they already do so. Yeah? You can do it on an Excel sheet, but this tool I'm showing you here is based on a BIM model. And this BIM model is read into Madaster. It's a great tool, but was internationally well known in the meanwhile in 7 countries in Europe and helps many stakeholders in the industry to actually focus on their circularity index, which is also driven by EU taxonomy. You can do life cycle assessments so you can actually evaluate your global warming potential, and the creme pass the corporate carbon risk real estate monitor. And even better, it hopefully one day will actually give us a chance to have even a platform that helps us dealing with reused materials with an urban mining screener that gives you a regional database of the materials that you can actually reuse in some of your buildings. Thank you for your attention, and I'm open for any questions.